recording. Yeah, so welcome. I'm Anders Malmqvist. I'm Program Director of the Sustainable Energy Engineering Master Program. And to my help, Samuel Löffler is a student in the program. We do have another student ambassador for the program, but Samuel stepped in today to give the students' view on the program. So let's go ahead with the presentation and then we'll continue. So. There we go. So the program is hosted by the Energy Technology Department. This department has a vision. We aim to contribute to the better world, like all of you attending this webinar as well. We do it through promoting transition in the energy sector towards increased sustainability. Our department, we have 3 divisions, so I will just start with introducing some heads. We have the division of Applied Thermodynamics and Refrigeration, which is headed by Associate Professor Hatef Madani. We have a division for Heat and Power Technology headed by Dr. Rafael Gudes, and an Energy Systems division as well by Professor Victoria Martin. And all the department is headed by Professor Björn Laumert. So the program, we have 3 different directions of the studies. We have the energy system analysis, we have energy supply through clean conversion technologies, and we have energy in buildings and cities.
तुला माउस नसेल पाहिजे तर मला देऊन टाक. तुला माउस नसेल पाहिजे तर मला देऊन टाक.
Okay, so now the program has been in operation for 25 years. Actually, you are the 26th student batch applying for the program. We started back in 1997 with only 14 students, but by now around 1,000 students have taken the program. And for the intake of 2024, we plan to admit 90 to 100 students. About 40% of these students are program students from KTH, and the rest are flying from all over the world. To be eligible to join this program, you need to have a bachelor's degree and preferably in mechanical engineering or chemical engineering. But it's also possible with another bachelor background. The reason we are saying that mechanical or chemical engineering are preferred, that's because in these programs, normally engineering thermodynamics, fluid mechanics, and heat transfer are included in the curriculum. But provided you have academic records in these courses, but another bachelor, then it's all okay to join this or to apply to this program. We also have the requirement on English language proficiency that you should have minimum TOEFL 90 and the written test minimum 20. Now some slides about the structure of the program. So when you start in the fall semester, there are 4 mandatory courses, and following that, for the spring semester, you select one of the 3 profiles, which you will recognize color-wise by their relation to the divisions I earlier mentioned. So we have energy system analysis, energy supply through clean conversion technologies, and energy in buildings and cities. For the final semester, during the full semester, you focus completely on your master thesis. And that thesis is preferably a deeper dive into one of the profile tracks which you select. But you can also select the thesis from another profile, provided you have the necessary knowledge, or from a completely different field where sustainable energy is an important factor. So there is a great flexibility to form your own thesis or select among the different theses provided by our department. So just to summarize then in words what I just said, during year one, there are courses subdivided into one of the three profiles. For the second year, also during the first semester of that year, you go deeper into the selected profile, but there is also room for elective courses, and the final semester was the master thesis. Here I will show some examples of how courses are set up during these semesters. So we have here the first semester and the second semester. Those are the first year. Then we have the third semester, that's the fall of the second year. And in the spring semester was the master thesis. So again, you start with the four mandatory courses: energy systems for sustainable development, renewable energy technology, sustainable power generation, and energy in the built environment. In the spring semester, there are two mandatory courses. One is a course in research methodology, and the other one is a course in energy management. Then during the third semester, there's only one mandatory course for all. That's the artificial intelligence applications in sustainable energy engineering. This is a brand new course, which is set up to visualize what's happening in this sector and applied to the energy engineering. Now, so these courses were courses to be taken by everyone in this program. Then we have the different profiles. That's this table. That's the profile for energy system analysis. And just scrolling forward, then we have a similar setup for the energy supply through clean conversion technologies. And again, same setup for energy in buildings and cities. And when I switch here, you notice that the structure is the same, but the courses differ a little bit. So on energy system analysis, then we look into transformation of energy systems and the climate agenda. We do analysis of the systems, and then in addition to that, you can select one of the three courses: district heating, numerical heat transfer in energy technology, or sustainable perspectives. For the third semester, there are conditionally electable courses, circular economy, energy system economics, and then 12 free electable courses, but we recommend that you take one of the courses listed here. And now for the other two tracks, you see there are somewhat different courses. This one, small-scale polygeneration, is given by myself. I will tell a little bit more about it in a few slides later. And the three courses for conditional electing is also the same, but these courses are different. And again, here we have another set of different courses. So based on any questions from you, we can come back to this for details in these courses. In addition to studying at KTH campus, there is also a possibility to go for 1 semester or 1 year of exchange studies, which means that you follow the program at KTH, but you actually spend your time with another university. And we have a list of many different university opportunities. So you can do one semester or a full year. If you do one semester, for example, the semester 3, then the courses you take at that university are accredited at KTH, so they are included in your curriculum, and you get a degree at KTH, although you have taken courses from another university, but these courses are mapped to each other. If you go for the 4th semester, then you also do your master thesis work with that university. So there are, in addition to exchange studies, there are also virtual exchanges, which means that through the Unite network, you could take one interesting course at that university by online opportunities while still being at KTH campus taking the rest of the courses. A little bit about the research in our different departments. The Division for Applied Thermodynamics and Refrigeration deals a lot with heat pumping technology, ventilation and heating for buildings, and a lot of simulations about energy use in buildings like supermarkets, residential buildings, and full cities. An important factor is heat transfer to actually be able to transfer heat to where we want it or from where we don't want it. The next division, Heat and Power Technology, we deal a lot with the generation of energy, electric energy and thermal energy. So in many cases, turbo machinery is involved from thermal power plants. Polygeneration, that's the combination of several energy services like heating, cooling, electricity, clean drinking water, etc. Fuel cell technology is involved, and different types of biofuels also, and not the least solar power. And we are to some extent specialized in concentrated solar power. The division for energy systems is a little bit different from the others, as the others deal with technologies and technical systems, while the division for energy deal with how to implement such systems on a national or a regional scale, and to evaluate which energy sources would be available in a certain region, how you make them accessible with a good energy efficiency, and so on and so on. How we go for circularity in a much broader sense than we do today. I mentioned polygeneration before, and here we have an example of a completely integrated system. Here we have a small village with agriculture activities. The waste from crops and from manure from cows, etc., is digested, forming biogas, which is used for cooking gas, but also to power an internal combustion engine with a generator. The generator produces electricity for the village, maybe together with some other sources as well. While the waste heat is reused to a membrane distiller to produce clean drinking water in the village, and also the residual heat from the membrane distiller is used to keep the digester at a reasonable temperature. This is an example of a system which we deal with in a polygeneration course, and Samuel is one of my students in this course, so you probably will become an expert on this, or let's see your opinion. I will continue with a few examples of master thesis projects within this program. It could be an analysis of a smart grid. This is an example of India, where a hybrid solar PV and wind power system has been evaluated and designed from rating and how to which extent it has sustainability or autonomy to be able to provide energy in a certain time frame when there is no grid energy available. The one in the center, that's a bit futuristic. In this case, a student studied how greenhouses in the Antarctica could be powered by renewable energy sources. And that's a preparation for a future travel to Mars and colonization of Mars. How could you, under very harsh conditions, provide circular economy, so to say, with the vegetables growing and the waste is reused to feed more vegetables. The third example is a bit more hardware oriented. This kind of concentrated solar power heliostat with a micro gas turbine in the focal point. It needs to be controlled, and the students set up control algorithms for that, and made a first implementation in a low-cost Arduino-based industrial PLC system. Also, research-wise, this is an example from the Andaman and Nicobar Islands in the Bay of Bengal, where our researchers and PhD students were involved in doing a pre-study how the fossil fuel-based generators could be replaced by a more sustainable renewable systems. As a result of this pre-study, it was proposed to utilize coconut and lycra nut residues and gasify them to provide syngas to operate Stirling engine that produces electricity and heat. And the residual of this pyrolysis is biochar, which can be used for further agriculture and fertilization of the ground. Now, so much about the research and the course setup. Now, I would like to leave the word to Samuel to tell us a little bit about being a student in the program.
Thank you, Anders. So, hello and welcome, everyone. I'm Samuel. I'm stepping in today for Hari Haran, who's the student ambassador for SEE, but he couldn't join today. I'm originally from Germany, and I started the program last year in August. I have a background in mechatronics, so for fulfilling the requirements, I had to catch up on thermodynamics and fluid dynamics before coming here. And I choose the profile of energy supply through clean conversion technologies. And as mentioned before, I will use the next semester, the master thesis, to go abroad. I'm planning to do my master thesis in cooperation with the University of Vienna on the transformation of a steel rolling plant. At that time, I decided for KTH because I knew I wanted to go abroad. And therefore, I decided for KTH as a very high-ranked university, especially in the field of energy engineering, and also thought I want to go where renewable energies are done right. And so I decided for Sweden, one of the countries with the highest renewable share in Europe. And about SEE, I especially like that it expands my quite technical background with mechatronics. So as you've seen, we have these courses in the field of energy systems analysis and also into energy applications, especially in the first semester, to have some broader overview. And I also really appreciate the big amount of group projects that are really good preparation for the work life afterwards. On the next slide, if you can change, I'm giving some impressions about my time in Stockholm. So in the upper left corner, that's me and my team. About 4 weeks ago, we had the energy management project in the second semester. In that project also has a competition at the same time. So the winning team can then win a trip to Barcelona, and the second team has won a trip to Valencia. And we actually became second team. So in 2 weeks, we will go to Valencia as our team from this project. A really nice reward for that. Then the bottom left corner that was taken at the SEE summer event this year, where first and second year and also professors and teacher assistants came together to have some dinner and play some games together. Then the other pictures give some impression of my time apart from university. So in the middle, that's the Christmas dinner we had in our Fletcher. I'm living in a private Fletcher with lots of international students from also mostly at KTH. And then we had some hikes. In the bottom right corner, it's when we went to Kebnekaise, the highest peak in Sweden. And in the upper right corner, that's when we went to Kiruna for some dodge sledging in the winter. Yeah, that's about my time in Stockholm. And I think now we thank you for your attention on the presentation.